Level Control Setup Test Experiment Mode 2. Mode 2 only has an automatic mode, not a manual mode. The principle is that after the PID controller 1 collects the liquid level, it outputs a PID controller output. Then the output signal is sent to PID controller 2. Instrument number 2 receives signal input from instrument number 1 and use its input signal as the set value and collect the flow rate. This is equivalent to converting the values in Table 1 into the flow target values in Table 2. Then control the proportional valve to link the two tables. Next, we will begin the experiment. The current state is the equilibrium state at the time of experiment 1. The values of PID1 are 9, 120, and 0 respectively. At this point, switch the mode switch to mode 2. After adjustment, the proportional valve is controlled by the second PID controller. The set value remains at 100. Observe the changes in the experiment. The liquid level change was not obvious. We can adjust the output values of the two PID controllers appropriately. At this point, PID1 is fully activated. PID2 output is small. Increase the p-value to 8. The output started to change. Because PID1 output is already 100%. The output of PID2 is also slowly increasing. This is a very slow process. Increase the p-value to 9. Output is still slowly increasing. The output of PID1 is also decreasing. The data changes can be viewed more intuitively through two PID controller instruments. The set point of PID controller 2 is the actual value of PID controller 1. Wait for a while and continue to observe the changes in the liquid level. After a period of time, because the effect was not obvious, the p-value was increased to 15. Increasing the p-value significantly speeds up the output. Because it involves the control of two PID controllers, the waiting time is relatively long. After several adjustments to the PID values, the actual value now matches the set value. This indicates that the actual value has reached the target value. The experiment was quite lengthy. The graph shows that the actual value has fallen below the set value again. floating around the set liquid level. Now adjust the p-value and observe the liquid level change again. After continuous adjustments and testing, the PID finally achieved the same flow rate set point as the actual value. The liquid level set point is the same as the actual value. The valve opening degree remains consistent. The only thing that changed was the PID value. The current value of PID 1 is 5,120, 0. The value of PID 2 is 8,120, 0. In the current state, it is equivalent to connecting to PID controllers in series. Thus, a state of equilibrium is achieved. The curves also completely overlap. As you can see, the liquid level and flow rate are the same as the instrument readings. This is the experimental demonstration of Mode 2.